Hi, welcome to this tutorial on solving quadratic equations in an exponential function. Now in this particular case the exponential function is 5 to the power x. And I can show you that this is a quadratic equation in that because what we can do is let's say a letter, y for example, equal the exponential function 5 to the power x. So therefore this equation becomes 3y squared minus 4y plus 1 equals 0. So you can see we've got a quadratic equation. This is a quadratic equation in y, whereas this equation is a quadratic equation in 5 to the power x. Now it is quite often possible that you won't see questions like this presented in this particular format. This particular term here can often be written as 3 multiplied by 5 to the power 2x by the indices rule, where you can multiply these two together. These two are equivalent to one another. So watch out for questions that are presented in this particular format. At first they don't look like quadratic equations in the exponential function 5 to the power x, but if you adjust this term here you can see that you can create this quadratic equation in 5 to the power x. Okay, so assuming then that you get something like this, you can change it into this format, and if you let y equal 5 to the power x, then you get your quadratic equation in y here. And so let's carry on now. When you get your quadratic equation, what you normally do is try and factorize it. So assuming that this factorizes, we put two brackets down. If it doesn't factorize, you can always use the quadratic formula. But this one does, because we can have a 3y and a y, and a minus 1 and a minus 1, and if you expand that, you'll see that you get that. Now that we've got it factorized, we can put each of the factors equal to 0, so therefore 3y minus 1 equals 0, or that y minus 1 equals 0. In which case, we're going to find from this one that y equals 1/3, or from this one, if we add 1 to both sides, we get y equals 1. And we know that y is 5 to the power x, so therefore 5 to the power x must equal 1/3, or 5 to the power x must equal 1. Now looking at these two equations, I'm going to start with this one purely because this is an obvious answer. When 5 to the power x equals 1, anything to the power 0 will equal 1. So x is clearly going to be 0. So therefore x equals 0. So that's one of the solutions. Now we need to solve 5 to the power x equals 1/3. So if we just come down here and we just write that when 5 to the power x equals 1/3, to do equations like this, if we can't see what the power of x is, just as we did in this example, what we can do is use logs. We can log both sides, let's say to base 10, so we just write log of 5 to the power x equals the log of 1/3. And by the power rule for logs, we can bring the x to the front of the log, so therefore we have x log 5 equals the log of 1/3. And if we now divide both sides by the log of 5, we get that x equals the log of 1/3 all divided by the log of 5. And you need to use your calculator now to work this out, but if you do, you'll find that you get minus 0.6826 and so on. So in other words, x is equal to minus 0.68 to 2 decimal places. Alright, so that's how you would solve an equation like this type. Okay, recognize that you can put this term here as 5 to the power x all squared, and you've got yourself a quadratic equation in 5 to the power x. Now I want to do another example where this particular part of the equation is in a slightly different format. So here it is. We now have 2 to the power 2x plus 1 minus 3 multiplied by 2 to the power x plus 1 equals 0. Now we need to modify this first term here. What we can do is that when you're adding, okay, powers here, it's the same as saying this, that this is 2 to the power 1 being multiplied by 2 to the power 2x, because there's to the same base here, 2, so you would add the powers and that will give you 2 to the power 1 plus 2x, or 2 to the power 2x plus 1. Then I've got minus 3 multiplied by 2 to the power x plus 1 equals 0. Now 2 to the power 1 I can just leave as 2. 2 to the power 2x, I can write that in as 2 to the power x all squared. Then we've got this term here, minus 3 multiplied by 2 to the power x plus 1 equals 0. And now you can see, hopefully, that I've got a quadratic equation in an exponential function, that exponential function being 2 to the power x. And as before, what I can do is just say let y equal the exponential function 2 to the power x. So therefore I have 2y squared minus 3y plus 1 equals 0. And I can factorize this, couple of brackets, and again if I struggle factorizing it, or if it didn't factorize, I can always use the quadratic formula. This factorizes to 2y and a y and a minus 1 and a minus 1. Check it out and you'll see that you get 2y squared minus 3y plus 1. And so what that means is that each of the factors would equal 0, so 2y minus 1 equals 0, or y minus 1 equals 0. And this leads on to y equaling a half, or y equaling 1. And when we have y equaling a half or 1, we know that y equals 2 to the power x, so therefore 2 to the power x equals a half, or 2 to the power x equals 1. Now these are obvious solutions, but if you didn't know them, you can always take logs to both sides. But let's just write them down here. Basically, when we have 2 to the power x equaling a half, x is minus 1, because 2 to the power minus 1 means 1 over 2 to the power 1, which is a half. So this is an obvious solution, that x equals minus 1. But if you didn't know it, as I say, you can always use logs, as I did in the last example. And also we have when 2 to the power x equals 1, that's this one here, the solution again is obvious. Anything to the power 0 gives 1, so therefore x is equal to 0. Alright? So hopefully you've been able to see how I've been able to turn equations like this into quadratic equations, and then we can solve them in the usual way that we do quadratic equations. Alright, and that brings us to the end now of this tutorial.